This is going to be a walkthrough explanation of the Infix translator. When we get to something like this, the project itself is a lot more abstract than code-based, so I wanted to actually do some animation walkthroughs of this thing. To begin with, we have up here our input string, so I put this in Infix notation and put the parentheses in. So open and close, 1 plus, open close, 2 times 5. And this little arrow is going to be pointing to which token I'm looking at. Then in my algorithm, which I have over here, I'm going to be using this arrow to point to where I am in the algorithm as I walk through it. This is going to be a stack, so just a reminder, a stack is a data structure where you can get things off the top, and that's it. You can't look at anything below there. So you push things, so if you see push, that means take a node and put it onto the stack and push everything else down. Pop means you pull one thing off the stack. And then if you see the word peek, like right here, that means look at the thing under the top of the stack, but don't do anything with it, other than see what it is. Down here is where I'm going to have my current node, and then later on when I have this top thing here, that's going to be a secondary node that I'm going to deal with. So let's begin. To begin with, the first token I'm looking at is the open parenthesis. So I make that into a node. This is a binary node right now with 2 null children. So I look at the first step, I say if token is an open parenthesis, just push the node on. There we go. Current got pushed on. So my stack currently consists of just this open parenthesis. I'm going to look at the 1 now. So I'm looking at that. I'm going to make that into a node. Here we go. It's not an open parenthesis, so I'm going to look at the next thing. It is a number. So I'm looking to see what happens next. So there's 2 possibilities. If the thing on the top of the stack, so if I peek, is this an operator? The answer is no, it's not. It's not a plus, minus, times, or divide. So I'm just going to push on the node. So now I have a stack with 2 things. This one, a 1 with 2 null children, and a open parenthesis with 2 null children. Next thing is going to be a plus. I create a node out of it. It's not an open parenthesis. It's not a number. It is an operator. So what we do is we pop off the top thing, the 1, and we make it the left child of plus. And then we take the plus and push that back on. Technically, there are only 2 things on, the plus sign and the open parenthesis, though the plus does have a left child. We do another open parenthesis. We create it, and its job is just to get pushed on the stack. Now we're looking at the 2. Once again, we create that. It's not an open parenthesis, it's a number. This is not an operator, so it just gets pushed on again. All right, the time sign, much like the plus sign, it'll get created. It's not an open, it's not a number. It is an operator. So it becomes the parent of the 2. The 2 becomes its left child, and we push the time sign back on. So this is the way our stack currently looks, as these 4 nodes. We get to the 5. We create it. It's not an open parenthesis. It is a number. Now the thing on top is an operator. This is an operator, the times is. So what we're going to do is take this off and make the 5 the right child of it. And then we push that back on. All right. Close parenthesis. This is a tricky one. It's not an open parenthesis. It's not a number. It's not an operator. What we do is we actually now have 2 things we're going to do. We actually never do anything with the close parenthesis. We actually just throw it away. What we do instead is we grab the top 2 things off the stack in order. So the times gets pulled, and then the open parenthesis gets pulled. Now this one's not very interesting, in that what happens is we say, well, top is not an open parenthesis, but it is immediately, so we skip this inside part, and we just push current back on. And actually, this open parenthesis gets thrown away. That's how we remove parentheses from the stack. The second close parenthesis is more interesting. So we walk down, it's not an open, it's not a number, it's not an operator. So once again, we're going to pull the top 2 things off the stack. Current is going to be the times, top is going to be the plus sign. So top is not an open parenthesis, it's a plus sign. what will happen is current becomes the right child of top, over it goes. Current becomes top, and top becomes the next thing in the stack. Now it is an open parenthesis, that gets thrown away, so we push current on. We've walked through everything in our input, and so there's only one node left, it's just the plus sign, even though it has all of these things that are left and right children down through it. And so the only thing left on my stack is now my expression tree. So now if I wanted to do this in infix notation, I would do 1 plus, because you always do left yourself and then right, 2 times 5. If we did prefix, you always print yourself first. So you do plus 1 times 2, 5. Postfix, you always print yourself last. So this one would be 1, 2, 5 times plus as I come back up. Hopefully that helps a little bit in explaining the Infix translator.